This is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Donn Felker.
And I'm Kaushik Gopal.
Welcome to episode number 17. I'm back, Kaushik.
It's good to have you back.
It's good to be back on the other side of the country, so we'll see how it goes today.
It appears you've moved further away. You're no longer nearby.
No, I am nearby, but just depends on what you mean by that.
I'm very proud of that joke, by the way.
That was good.
Yeah,
that was good.
It was good?
Yeah.
Are you happy?
I didn't expect that, really. I was like, oh.
Are you happy to be back on the show and make sure I don't take this down and lose every single listener that we have carefully acquired over the time?
And I think you're doing well. I think I might bring down the quality a little bit myself, so I don't know.
It's good to have you back, Donn.
Thanks. So we did have one housekeeping thing we wanted to bring up is a lot of people had asked for the show to be hosted on SoundCloud. So we are publishing the files now to SoundCloud. And you can just go to soundcloud.com/fragmentedcast. So if you have the application on your Android device and you'd like to listen through the SoundCloud app, you can listen there or continue to use your favorite app, such as Pocket Cast, which is mine, and continue going from there.
Yep, that makes sense. I also had a quick bit of follow-up from our last episode. Listener of the show, Jonathan Maltz, sent us a tweet mentioning why the view property animator is more efficient. We mentioned this in the last episode with Amanda. It's because there are actually fewer calls to the invalidate method. I'll add a link to this in the show notes. Also, a longtime friend of the show, Dan Liu, reached out to give us a heads up on Retro Lambda, which we also talked about in the episode with Amanda. The one issue that he mentioned in a previous episode, the common issue that most people using Retro Lambda usually run into, has actually been resolved, so that's no longer a problem. Unfortunately, there's a new issue now, but this has to do only with the tooling, and you'll probably run into it only if you have a pure Java submodule. So I thought it made sense to just mention that because some of these good folks reached out to us and let us know of this information. In the episode, we talked, I obviously, because Donn wasn't here, as usual, I couldn't pull the exact thing off correctly. We talked about a tool where there's this view hierarchy, and Amanda mentioned that she heard of a tool where you could visually see this hierarchy in a 3D fashion, like swoop it around. I thought Stetho, the Facebook library, did that. I was incorrect. It was actually written by one of the Facebook engineers, I think, as a private repository. It's called Droid Inspector.
Okay, cool. And then I think is that similar to Jake Wharton's Scalpel at all, or is it different?
See, Donn, this is why you shouldn't miss any of our episodes. I just go on and say things that are just completely crazy. Scalpel is an amazing tool. I totally forgot about it. There's just one difference. I guess it doesn't run, you can't run it on your machine, on your PC, your Mac, etc. It runs on the device, but I mean, that might actually be a better thing. Okay, that's the follow-up from my side. Great.
So what are we talking about today? You mentioned something about a good joke that you had earlier, and that was at the beginning, but I think it kind of relates to what we're talking about today. So what are we talking about?
We have two fine gentlemen with us from this company called Alphabet. I'm not too sure. I mean, I've never heard of the company, so I thought it was maybe some.
Do you know what Sesame Street?
Oh my God, we're going to land into so much trouble, Donn.
Hi, guys.
Good to have you guys on the show.
Everybody, we'd like to welcome the nearby, I guess it'd be, I don't know if it's the entire team, guys, or just a few of you guys, the nearby folks from the Google/Alphabet team.
Just a couple of us.
Just two of us.
Okay. Yeah. How many are on the team?
It's pretty good sized. Maybe 17 or so.
Okay, wow. That's huge.
Nice.
So, Andrew and Akshay, would you guys, let us, the listeners, know who you guys are and kind of what the nearby, Google Nearby is, and so we can kind of discuss it a little bit in deeper content?
Sounds great. So my name's Akshay Kannan, and I'm a product manager on the Nearby team.
And I'm Andrew Bunner. I'm the eng lead for Nearby. I've been at Google for over 7 years now, mostly doing backend stuff for the first half of that, and then transitioned to mobile kind of on the second half, and kind of stumbled on the Nearby opportunity, and we're really excited about it. We've been working really hard on it, so we're really pleased that it's finally out there and people can download the SDK and actually use it now.
Nice. I had another amazing joke before last week. The update to Play Services hadn't come out yet, so I was like, is the Nearby API coming anytime nearby? But then I realized that was a bad joke and also
Almost.
Grammatically incorrect. So,
But really close, really close. Partial credit. So maybe we should start with what exactly is this?
Exactly. That'd be a good. Could you guys give us the kind of the rundown on what it is?
Yeah, so it's an API that lets devices discover and communicate with each other when they're nearby. And by nearby, like lowercase nearby, we mean about 100 feet. And we have an option to do something, closer range, about 5 feet. But the default's about 100 feet. And so you can build all sorts of experiences on top of that. But in a nutshell, that's what it is.
Now, Andrew, I saw your, was it one of the episodes of the 100 Days of Dev, where you explained Nearby, and that made sense to me because my immediately first question was, okay, why would I need this if I already have, Bluetooth and Bluetooth Low Energy and NFC and so forth? The video explained it well, but could you kind of give the listeners a rundown of why should we actually, why as developers should we care about this if we have all these other technologies and such?
So we think it's actually pretty unique. We certainly started looking at these other technologies because they're sort of like the obvious like jumping off points, but each one of them has like one deficiency or another that makes it not quite perfect. So if we sort of like run down that list, like the most obvious candidate for doing proximity is really location. Right? Like turn on the GPS, like get location. If two things are close together, done. The trouble with that, there's actually a few problems. The first is that it's spoofable. So if you wanted to really know with high confidence that two devices are near each other, location is probably not the best choice because of things like mock location provider, where in an emulator you can just pretend to be wherever you want. The second issue with location is that indoors, it's actually not that accurate. And that's because the GPS signals like usually don't go through the building. So you're not going to get the high accuracy that you would get with like an outdoor GPS. So that was location. BLE is another. This is Bluetooth Low Energy or Bluetooth Smart. Another great candidate technology. It's been on iOS since I think iOS 7, I want to say. And Android has had scanning since Jelly Bean MR2, and it just got advertising in Lollipop. And the issue there is that you really need both scanning and advertising to like do the discovery. One side does one, the other side does the other. And the advertising capability hasn't really deeply penetrated the Android ecosystem yet, so it doesn't have quite the coverage that we'd like. And then we've got suggestions like NFC or like QR codes, and each one of them has their drawbacks. With phones that are getting like bigger and bigger, it's sometimes hard to line up the NFC antenna just right. And that's like, you think something so mundane is like, well, like, of course you just kind of like, but it actually is like a little bit of a usability issue on these large phones. And QR codes I think are pretty cool. They haven't actually taken off that much in the West. And besides that, they have this kind of technical constraint that if you have a low light condition, a really bright screen is hard for another phone to focus on. So you can imagine if you're in a restaurant or a bar or something.
Interesting.
A little bit hard. So what we kind of set out to do was like, how can we make proximity work everywhere? Like that was really what we were going for. And when we say everywhere, what we really mean is like both iOS and Android in a way that they can both like discover and talk to each other. And that was kind of like the genesis for the project, is solving that problem.
Nice. So that's actually one question that I had initially when I saw you folks put out a video that Donn was mentioning. How should one really think about nearby? Because like you said, the first thought that came in was also like for me, I could do this with location, right? With the location information, you could set up these zones and almost achieve what you want with nearby. But you mentioned an interesting point where like accuracy is obviously one of the biggest drawbacks with using something like location. Also, you mentioned another keyword called proximity, right? So proximity is also, I think, a nice way where I could immediately understand what you could do with the nearby API, right? How should one really think about nearby APIs? Is it just a convenient sort of service where I could immediately send or receive information with people around? Or does it also extend towards even maybe like services like beacons or like maybe devices, like non-humans on the other side?
Sure. I could talk a bit about that. So basically our goal with the Nearby API was to kind of build this abstraction layer around all of the different underlying technologies and just build this dead simple API for proximity. And as you mentioned, it's not just for proximity between users, but it could be proximity between different devices. Andrew had mentioned Android and iOS. And actually another example of where we use Nearby is with Chromecast. We have a feature called Chromecast Guest mode where we use Nearby using ultrasonic and Wi-Fi scans on the Chromecast to establish proximity with the device and let you cast to it even if you're not on the same Wi-Fi network. So kind of the idea behind Nearby is we want to, as a developer, you shouldn't have to think about all these individual technologies. You just want to get two devices together for some kind of cross-device experience. And we can use the Nearby API to just give you a simple publish-subscribe interface for that.
So you also mentioned beacons. It's worth mentioning that Nearby works together with beacons. So you can use Nearby to scan for beacons and so get access to attachments or payloads that you've associated with those beacons. When I say beacons, I guess I'm not sure everyone knows what they are, but BLE beacons are these little sort of standalone devices. They're usually battery powered, and they like emit a very kind of like low energy, Bluetooth low energy pulse. And that's like detectable by phones, and you can sort of use them for like improving location or, detecting if you're nearby some, kiosk or maybe a painting at a museum or something.
So you folks were on another podcast that we listened to. A friend of the show, Rusty, was the Material podcast, and you mentioned the way, like you mentioned ultrasonics and how it actually works. I thought that was amazing. It was mind blowing because you prefaced the statement saying that you wanted to move past different platforms, so iOS, and even go back for certain devices. Like even if you had to aim for devices that were like on previous APIs or try to use a technology that most people would have on their mobile devices. And yet you said like the Sonics thing. And it didn't make too much sense to me. I was like, well, that seems like something new that they probably might have added. So I think this is a nice point to maybe transition into how really does it work? Because you said it also works with beacons. And again, I have very little knowledge on beacons, but do beacons, like you mentioned a pulse, but do they also emit like a sound or something? Or, I mean, how does that work? Like, how did you manage to get Nearby working even with beacons? And maybe we should also like get into how it actually works.
So it's a multimodal solution. So most beacons do not emit ultrasound. They just emit the BLE pulse. You got at the heart of it, of like why we started looking at sound, and it's for coverage is kind of the number one reason, because you simply cannot make a phone without a speaker and a microphone. Those two components are going to be on every single phone, even pre-Gingerbread, really. So that was sort of like one motivating factor. And the other thing that we sort of came to really like about the audio technology is that unlike radio waves, audio does not go through walls. And that has this property where, if something is nearby and sort of in earshot, that sort of mirrors the privacy expectations of the real world. Like if you could overhear my conversation, then I can sort of like see you, and it's the same kind of thing with devices that are nearby. And so that's one of the reasons why the Chromecast Guest mode, why we're able to launch that is like a concern was if you are near my Chromecast but not actually like in my house, we would not want you to be able to cast to it. That would be sort of a disaster.
Interesting.
All sorts of hilarity could ensue. So that was kind of like one of the kind of motivating factors there. The actual development of that technology was involved. I would say.
I can imagine.
To put it lightly.
Yeah, Google has some really smart people, and we leveraged some of the audio researchers in Google to help build the codec for it, and it's built on top of a signal processing technology or a signaling system called discrete sequence spread spectrum, which is a mouthful, but what it means is you take your data and well, let's see, how do I explain this most easily? So you start off with kind of like static, like a static noise, just kind of like random noise. And then you modulate that random noise with your data. And then for us, we moved that modulated noise way up the spectrum so that it was outside the range of most human hearing. And then what you do on the other side is sort of even more complicated. To actually decode it is a real challenge because of multipath echoes. In other words, the sound sort of bounces around the room, and you'll get back the sound that was broadcast multiple times, sort of overlapping each other because it bounced off of the right wall and the left wall and the ceiling and the floor and so on. And you've got to kind of like piece those echoes apart.
Wow.
So that was a lot of like running around and like getting audio samples and stuff. But we're really happy that we went through that. You guys don't have to. Anyone who uses the API.
All you have to do is understand discrete sequence spectrum and just slap it onto your device. Write a couple of APIs and you're good to go.
DSSS for short, but
DSSS.
You mentioned an interesting point because with audio, it's actually pretty difficult. Like you said, it bounces around. That's not usually the case with most other technologies, like with NFC probably, because it's a sort of like direct one-to-one payload transfer, right? Versus with audio.
Sort of. So with NFC, that is true. NFC does not bounce around because it's so tight range. But other radio signals actually do. We've learned a lot about how like 2.4 gigahertz signals propagate in working on this project, way more than I ever thought I would learn. So they actually do have multipath, but you're not sort of exposed to it because it's kind of handled at like a much lower level. But if you're processing a raw audio stream, then you are exposed to it. Now, it's worth mentioning that for users of the Nearby API, and Akshay was saying it really just presents a very simple publish-subscribe interface. But for users of the Nearby API, you're not exposed to the raw audio. You don't get the audio. That's all abstracted away. And what you see is just this publish-subscribe interface where you can exchange payloads with other devices that are nearby. And so there's that I think abstraction is powerful. It really helps developers kind of simplify and like just focus on their features.
Now, because a lot of these audio signals and radio signals, they'll bounce off of walls and objects and so forth. Does this mean that this technology is a one-to-one or a one-to-many or what? How have you guys designed this?
So the way that it's designed is it's basically many-to-many in the sense that the API itself is publish subscribe, and in terms of we've kind of designed it in a way where the actual what happens in an audio setting doesn't necessarily match up to what you do in the API. So kind of regardless of whether you're publishing or subscribing, we're smart about detecting if there's already ultrasound in the room. And if there is, we will just send that token up to the server and join a group with the rest of the people. Okay. And if a device doesn't already hear ultrasound, it'll play ultrasound of its own for other devices to receive. But basically, it's many to many, and what happens in the API doesn't also really have to map to what happens in an audio signal standpoint.
Gotcha.
So just like a good example of that is, I heard Donn, I think, mentioning that Pocket Cast is his favorite podcast app. So if in the new version of Pocket Cast, if you go to the Nearby tab, and we had a blast working with the Pocket Cast team on this. If you go to the Nearby tab, with other people, then what you see is kind of the union intersection of everyone's podcasts in the group.
Right.
And so that sort of highlights the kind of many-to-many nature, is that like we all see like which podcasts are missing and which ones the other ones people have, and like how many people subscribe to each different one. Yeah,
Nick Butcher had tweeted about how interesting it's going to be at DroidCon NYC to be able to visualize what are the similar podcasts between all the Android developers. So this should be pretty interesting to see in the wild.
Yeah, I want to see that screenshot.
It might be a little interesting. Like
Friendships will be broken and focused is all I would say.
That's right, the dog-eat-dog world of Android podcasting.
I know, right?
Right.
Yeah, we like to think of it sort of as ad hoc groups. So basically, without having to have any sort of prior established relationship, you can just establish a group by being near people.
I think that's pretty cool, especially in a small conference setting. I mean, it would even be more useful. I used to run a Give camp up in the Twin Cities when I lived there, and we would have different teams working on different projects and have them to have a little group communication platform and be able to kind of come into the groups. Ad hoc would be really useful as like a organizer or even a member to one of those events.
Yeah, that's actually a perfect use case. I mean, when we think about like how Nearby can be applied, forming ad hoc groups for like messaging applications or kind of contact sharing applications, sort of in lieu of business cards, like that's kind of a really obvious solid use case for Nearby. Another one is that's kind of related is multiplayer games. Setting up the multiplayer game where you sort of want to play with the person who's sitting right next to you, that can be made much easier with Nearby. And in fact, that was one of our first integrations was with the Google Play Games team.
Okay, interesting. So I think, but it's important to mention, like when you say multiplayer games, it's essentially to set it up in the sort of handshake between the different phones that intend to sort of like start playing the games, right?
Yes, that's a very important distinction. So Nearby is not like an ultra low latency, high bandwidth solution, at least as it exists today. What it's good for is discovering and then like doing some initial message exchange, and then once you've actually discovered and sort of found the devices that are nearby, if you want to do continued communication, really what you want to do is switch to something else afterwards. So one possibility is you could switch to GCM messages. Another is if everyone's on the same Wi-Fi network, then just peer-to-peer Wi-Fi is sometimes an option, and that's actually the approach taken by the Nearby Connections API, which is kind of like a sister API to Nearby Messages, and that API is for multiple Android devices that are all on the same Wi-Fi network, and it also does discovery, but it has this different property where once you've discovered, then you can establish a socket to the other devices, and you can do very high bandwidth, like low latency transfers. And that actually is made for the gaming session.
Wow.
I had two quick follow-up points to what you just mentioned. So one is the many-to-many sort of explanation that we gave might seem a little daunting, but that's what the technology is sort of capable of. Like you guys mentioned, we had a look at the API, and the API is actually much simpler. All you have to worry about is the connections that are going out of your device and coming into your device. If you just manage that and think of it in that aspect, then I think it makes it much more simpler. Is that a sort of fair assessment?
Yeah, I think so. I mean, I sort of think of it as the messages that the app is receiving. So I as an app developer, I might want one instance to sort of publish a message, and then another instance to subscribe and sort of receive that message, and then what you do with it from there is kind of up to the app.
Okay.
And so there's kind of two different modes that we've found are common. One is where you've got one side publish and the other side subscribes.
Mm-hmm.
And the other mode is symmetric, where both sides publish and subscribe. And that's the case for, let's say, Pocket Casts, where I am publishing my subscription list and I'm subscribing to your subscription list.
Okay. So is there like a sort of contract that, like, does it have to get kicked off by a single device, or is it just broadcast and then you can sort of like tap into, it's almost like a radio, it keeps going on, the information is like going through the radio waves and you just sort of like tap into that specific spectrum to sort of understand the information that's coming in?
I'd say that's probably a pretty good, the broadcast analogy is probably appropriate. The one sort of distinction is that the messages are really by design, they're only exchanged between apps that have the same developer key. So they have to be associated with the same project ID in the Google Developer Console.
Okay. That makes a lot of sense, yeah.
Yeah.
No, we're kind of talking about messages now, so I'm going to kind of jump ahead a little bit than what we'd planned. Now, we're talking about sending messages back and forth between applications, and in the video it describes it, fairly well, that you can use different formats. Can you guys talk about that a little bit? Like, do I have to use JSON, or do I have to use protocol buffers, or what's the message format, and how do I use it? And is it fast? Is it slow? A little bit of detail on that would be great.
Sure. So the answer there is basically anything you want. We let you effectively send us bytes in any format that you want. So it's just up to you as a developer, whatever format you use. Just be prepared to deserialize that on the other end. But we leave that open and completely up to the developer. So you can use JSON, protobuf, CSVs,
Thrift, you name it.
Yeah.
XMLs? Do you do XMLs?
XML,
That's
sure.
You can. It's up to you.
That's critical. I mean, it's essential.
Go straight SOAP like you always wanted to do, Kaushik.
I know. Good old days, the good.
I mean, there is sort of a practical size constraint on these things. So,
No, that's a good point, because right now I'm dealing with stuff where I'm going over the transaction size on AIDL stuff because our messages are too big. So what is the message limit on these?
So it's. I don't want to say as I'm saying this, I want to caveat and saying this is not a hard contract that I want to to be there for all time. Mm-hmm. But at least today it's 100 kilobytes, and there's the sort of double asterisk after that is that if you keep the messages below about 3 kilobytes, then they're delivered faster to the other side because we can GCM ping them down to the other phone as opposed to having the other phone pull the server to get them.
Okay.
Oh wow! So it sort of plays off the GCM technology. It doesn't just.
Oh yeah.
Ah, okay.
Yeah.
Okay.
Maybe I should actually explain how it works in a little more detail. We sort of skipped over that. So the kind of sequence of events, this might be hard to visualize, but we'll do our best here. The sequence of events is if I have two devices.
I think you should start off by saying, close your eyes.
Okay. Close your eyes. Imagine you've got
Deep
two
breath.
Nexus 6 phones. One's in your right hand and one's in your left hand. So
There you go.
the phone, yeah, okay. So the phone on your right, let's say, wants to publish a message. So what it's going to do is it's going to call the nearby API, say, publish, and it's going to pass a bag of bytes there. And that message will go up to Google servers. The server will allocate a token to the device. And a token here is just a random number, basically. And the device is going to use all of its kind of radio technologies and audio technologies to get that token across the air gap to the other phone. The other phone, meanwhile, does subscribe, and it in the subscribe call, it gets its own token. It starts scanning for other tokens. It broadcasts its token as well, and once one of the devices has seen the other's token, then it sends that up to the server and says, "Hey, server, I've detected this token. Do you have anything for me?" And the server will say, great. Here's the message from the other phone. Do with it, whatever it is you need to do. So in other words, the message is not being passed over Bluetooth or BLE or audio. Audio is actually very low bandwidth, so not a great solution for that. The message is being passed through the server, and we're just using the audio to kind of pair them up. And that's one of the reasons for that is that between iOS and Android, there's actually not a really good peer-to-peer communication mechanism.
Mm-hmm, mm-hmm.
And so to make sure that everything worked everywhere, this was really the best option.
So you did say, you brought up a few times, the messages need to go up to the server and generate some IDs and so forth. So does this mean that the users of this technology actually have to have a network connection to the internet for this to work?
They do today, yeah. We recognize that's a limitation, but they do today.
Okay. In this amazing visualization, I must mention, I could totally see how that was happening. The device token that you mentioned, is that similar to the GCM token, or is it actually
it's
independent?
It's a different thing. Yeah,
okay.
it's a different thing. Yep.
It's an ephemeral ID that we generate just for that session for nearby.
Oh, interesting. So it's session specific.
Yes. Yeah, that's really important. So you get a different token sort of every time you use nearby, and that's
okay.
yeah, that sort of prevents tracking use cases or things like that.
So diving in a little to sort of the API and getting into specifics of the implementation, is there a min sort of SDK or a min API compatibility for this?
So the API is part of Google Play Services.
Okay.
So basically, any device, Gingerbread and above, can start calling it using the Google Play Services SDK.
Oh, fantastic. So it comes down as part of Play Services. And what's the version of Play Services that this is out?
7.8. So 7.8. So if you go to developers.google.com/nearby, you can kind of get started with the samples and see how to use the API.
Perfect. A quick question I had. So you said it works across iOS. So
Yes.
how does one implement this in iOS? I mean, just out of curiosity. So if I'm in a company and I have my iOS folks sitting across the table and I'm like, hey, we should try this nearby SDK.
Yes. You should totally try this nearby SDK. So it's really simple. On iOS, we published it as a CocoaPod.
Okay, CocoaPod.
Yep. So you just include this CocoaPod with your app. It's worth noting that iOS has this runtime permission model, which actually Android has as well now in Android M. And so what we do is on iOS, we have kind of a pre-permission prompt where before we sort of like try to use the microphone or try to use BLE, we kind of explain to the user like, we're going to need these technologies and here's why.
Interesting.
And then you'd get the OS level prompts. And if your app already has a microphone or it already has like Bluetooth permissions for some reason, then we kind of trim down that pre-permission prompt.
Okay. That makes sense.
Well, I guess that I should probably mention that on Android, this is a runtime permission, even on pre-Marshmallow devices. So that's, I think that's actually pretty important to developers because it means that you can add a nearby feature to your app, and the app will continue to auto-update, without users having to like sort of re-accept the permissions.
Interesting. Yeah.
The idea is like on Android, you don't have to directly request microphone or Bluetooth permissions, but simply all you have to do is at runtime you can call nearby, and then we behind the scenes will use those other permissions. But because you're not getting access to raw audio, you don't actually need the microphone permission directly.
Okay, excellent.
That makes sense.
Now, you guys had talked about there was two different types of tasks in the good explanation of kind of how it worked at a high level. Now, there's two different types of tasks, and those are going to be like our publication and subscription. And of course, I'm just going to assume if you're publishing data, you're going to use the publication task. And if you want to get some data from a device, it's going to be a subscription task. Can you guys talk a little bit about those? Or are there any subclasses of those? Or should I be worried about subclassing anything like that? Or what's your guys' thoughts on those tasks, and what are they used for in general?
So I think the tasks you're referring to are actually pieces in the sample. They're not actually part of the core API. Okay. So the core API itself has really two or maybe three like key methods. Nearby.messages.publish, and that takes the most important parameter that takes is a message object, and you don't need to subclass that. Just the message object constructor takes a byte array. Put whatever your message is in there. And then nearby.messages.subscribe, and that takes a message listener. And the listener, that's where you have your callback for onFound, and that callback gets triggered whenever a nearby publication is around. So those are kind of the two most important pieces of the API. And the third one is I think this is in 7.8, or maybe it's in 8.0. Might be in 8.0. There's an API called Get Permission Status that lets you quickly check if your app already has the nearby permission or does not have it. And that's sometimes useful because when you call publish, if you don't have the permission, you're going to get back an error, and in that error will be a way to like bring up the permission dialog. And if you wanted to know ahead of time the publish is likely to succeed, then you could use Get Permission Status.
Okay.
So that's that, and I guess on the message side, there's nothing really to subclass. All the message is really just a wrapper for your application specific payload.
And that payload is just like you said, is that just going to be bytes, right? I'm basically just sending you guys byte array.
Literally a byte array. Yep.
Okay. And so then it's my responsibility to worry about, all right, am I sending a protocol buffer? Am I sending you something from Wire or JSON or XML or whatever? And then worrying about how to deserialize on the other side.
Yep.
Okay.
That makes sense. We'll also add a link in the show notes to a specific. So Google's been doing this amazing job with sort of releasing these projects in Google samples. So there's an Android nearby link that Andrew and Akshay sent us, and that's amazing. It was very clear for me to sort of understand how the API works just from looking at those samples.
Now, one last question about the messages. You guys have worked with it longer than anybody else, so what would your recommended type of message that's going to go across a wire be? Do you guys have a preferred method that seems to just work better with the system, or does it not really matter?
It really depends on the use case. So we find typically folks are publishing like application-specific identifiers. So they might be like, user IDs, or maybe like a document ID, or maybe like a group ID for an ad hoc group.
Okay.
Those are pretty common things. Or it may actually be some configuration data for the app. So in the case of Pocket Cast, a subscription list, I have an app that I use that I wish used Nearby. It's like an app for looking at security cameras. And every time I get a new phone, which when you work on Android is pretty often, I have to go retype in all of these, this camera configuration on each new phone. I wish I could just I know that file is really small. I wish I could just say publish on this phone, subscribe on that phone, and be done. So that's sort of like another class of example. I think but it really is kind of up to the developer. We don't know all of the cool things people are going to build with this, so we're kind of excited to see what people do.
I could see a lot of uses for this. When I used to work at MyFitnessPal, helping them do stuff, I could see a lot of users wanting to take recipe data for what they're doing for their health and fitness, and just being able to send that over to their partner, or personal trainers taking a meal list and saying, hey, I'm going to send you these 3 or 4 meals over to your phone. Just install this app. It could be super useful for stuff like that.
Yeah, absolutely. I mean, you mentioned fitness and meals, which are 2 of my favorite things. So I wish I could go to the gym and then see what workout music other people are listening to.
Yes.
That would be fun. Or when I go out to dinner and we want to split the bill, it would be great if we could press some button and it would sort of all automatically happen. This, I think there's a lot of applications.
Definitely.
So one question I had, so you mentioned about going to the gym, going to the restaurants and stuff. And the first thought that immediately came up is there are 2 ways of thinking of this. One is when you want to sort of share this information, right? And I'm guessing for privacy concerns, this isn't something that's globally available to anyone nearby. You sort of have to sign up to listen to these, to this information that's coming through the wire through the Nearby API, right?
Well, it's protected by this runtime permission. So the user is going to know if the app is trying to do something with Nearby, because they had to grant that permission specifically.
Okay, so but once they've granted the permission for subsequent calls, I guess at that point it just comes down, right?
Yeah, for subsequent calls, you're really kind of trusting that the app is doing something reasonable, and that's kind of the same as any other Android permission. If you grant an app access to your contacts, you kind of sort of trust that it's doing something reasonable with them. It needs them for a good reason.
That's fair. So I guess it's up to the application developer then to know when to broadcast this information and sort of receive it on the other side.
Yes. So our kind of guidance is that a kind of reasonable best practice is to have some kind of UX affordance for enabling Nearby, and have both people sort of do that on each side.
Okay. Oh, that makes sense. Okay. So I guess in that case, if you had the Pocket Cast app and I had the Pocket Cast app, and I say, okay, I'm enabling Nearby so that I can sort of gather all the information I can for people who are around me that use the same, that listen to the same podcast, then you would have to turn that Nearby option on your device in order to be able to see it, so that everyone can share this information. That makes sense.
So Akshay's brought up there's on developers.google.com/nearby, there's a page for developer guidelines, and that sort of goes over what we think are the best practices.
Yeah. In particular, around just user flows in general, we really want to have some kind of explicit action that both the sender and receivers or participants in a Nearby experience take within your app to make it clear that something nearby is going on. So whether that's going to a Nearby section of your app or tapping some kind of button to activate Nearby, that way it's kind of everyone is doing this action. They know that they're doing something nearby. And also even just from a usability standpoint, it's nice because everyone is sort of actively involved, and as soon as things happen, they're going to get real-time feedback and can react to that, and they're more likely to complete whatever flow they're trying to do to get a bunch of devices together.
That makes sense. Now, this might be a stupid question, but and you probably might have explained it, but I maybe didn't catch it exactly. Is there a possibility, so if we have 3 people in the room, right? So you have you folks, Donn, and me in the room, and I'm
visualizing this, by the way.
Excellent. Yeah. Close your eyes. And now, Donn, I don't want to share some things to Donn. I want to send it only to either Andrew or Akshay, because
always doing that to me, man. You're always doing that to me.
So that level of access control is really up to the application developer, because the Nearby API itself is more of kind of a broadcast model, like we were talking about before.
Mm-hmm.
So there's kind of two ways to tackle your use case where you want to leave Donn out of things.
Mm-hmm.
And I don't know what you guys have going on between you, but let's say that you wanted to do right in front of Donn, share something to other people, but not to Donn.
Okay.
So one way you could do that as an application developer is you could have the other people in the room publish their identities, and then you subscribe to their identities, and you sort of see like, oh, okay, Akshay and Andrew are in the room. Let me pick them as the people to send to.
Excellent.
So that's one approach. And that's actually
I could another approach. Actually, one of our partners did this. So one of the partners who's integrated Nearby is Trello, and they have this notion of an organization that you're a part of. So they can do cool things like when you're publishing a message, they can scope that to only other people who are in the same organization as you. So that way, information doesn't leak out of a structure or something that you have set up in advance.
And would it, so I guess it would be on me then to also send Donn a message saying, hey, I'm sharing something with them, but I'm not sharing with you. That's also possible.
If you want to maintain that friendship, yes. It's definitely an option.
Well, it depends on what he's sharing, right? Indeed.
Okay. So a question I had with regards to the API design, and this is more from a developer perspective. What are your thoughts when you designed, like what were your thoughts when you designed the APIs for Nearby? Because the naming is really good. And I mean, I must come out and say, like, sometimes I have criticized Google for like their naming conventions. I'm not too much of a fan, especially in the testing side, but that's for another show.
I think we actually had naming professionals come up with this name for us.
Yeah, it's funny actually from a naming standpoint. At least in my experience at Google, naming has been one of the single sources of bike shedding I've ever encountered. It's one of those things where it's hard to please everyone. Everyone has an opinion. And reaching consensus is such a challenge.
You think you have a great name, then you look it up on Urban Dictionary, and you're like, oh my goodness, we cannot name it that. But with Nearby, like once we saw that one, we were like, hey, wait, yeah, this describes what it is. It's like really simple. Like this is like people will understand this. So we were really pleased with that. You also asked about the API design, and I'm thinking in my head like, oh my goodness, like which time? Because we
sure. I'm pretty sure it wasn't as simple as, okay, I shall close my eyes, I will come up with the API design, and boom, I'm ready to go.
Actually, we came up with it in our sleep, and then it came to us in a vision.
That's how you knew it was perfect.
Well, the first vision was not so great. We went. Internally, we were calling
was it a discrete
for a while.
sequence spectrum?
Discrete sequence spread spectrum. Try saying that fast. So we went through like a few different iterations of it, and the one that we landed on. I think after you create something, you can always look back and say like, I wish I'd done X a little bit differently. But I'm really pleased with what we landed on, and what I like about it is that it lets the application developer sort of overlay whatever concept of identity or kind of whatever they want on top of it. It's sort of very flexible from that perspective. And it's also really simple in that there's really kind of like two operations, and they sort of like very clearly go together. So those were like two of the things that we were pleased with. It does have some sort of like other options that you can pass to it, and we kind of encapsulated these in what we call a strategy object. And for people who want to do like really fine-grained control over like what the phones are doing, there's things you can do like you can set a strategy where you say, I only want this phone to scan, or I only want this phone to broadcast. And that's useful if, for example, you have an asymmetric use case where like one phone is like sending something, the other phone's receiving it. In that case, you can set up one to be the scanner and one to be the receiver. And that'll make the discovery process a little bit faster because they don't have to kind of like, bounce back and forth between broadcasting and listening.
So should we expect to see some of this at Google I/O next year as we walk by certain little pods and nearby information?
Well, I mean, I guess that's a long time from now to sort of speculate. but I will say
done. Very smooth.
Well, you also. I mean, I guess I will say that because it works with beacons, like that's the kind of experience that can be enabled. So you can have like a you could display some information relevant to a beacon that you're nearby.
Excellent.
And while we're at it, what are the next Google Nexus devices, and do we get one for free? Because we're all sharing here.
I tell you what, the worst thing about working inside of Android, and I'll say I love working inside of Android, but the worst thing is the phone that I want is always the one that's not released yet.
I don't know. I never really wanted a Nexus 6, but to each your own, I guess.
Yeah, I've gotten used to it. Like,
It
I've got
grows on
two of
you.
them. I think
Or
actually
you grow on it.
Given the plentiful amount of space on the screen.
Yeah, I literally have two of them right now. As
That's
one does
hardcore.
at Google. Well,
Two of them.
you've got one with the latest OS and one with the OS just before that, and
Especially being on the Nearby team, when we work on features that work across multiple devices, it's pretty normal for all of us to walk around with a bunch of phones in our pockets.
you never know when you might need to do a demo.
Cops pull you guys over. Oh, look at all these burners.
Out of curiosity, what devices do you guys use, like as your personal device?
The two Nexus 6s.
Okay.
Me personally, I'm always switching SIMs, and I'm always changing the personal device that I'm on. So currently, I happen to be on a Nexus 6, but at times I've used the Nexus 5. I'm on a Samsung device. I was using a Xiaomi device for a while.
Oh, interesting.
I was using an iPhone for a short period of time. I went through that phase. So I'm always trying to try different devices out and see what's out there.
Did you say iPhone? Get this guy out of here.
It was everyone goes through that phase. And
Okay. So another question I had was with respect to the battery and power drain, right? So are there certain things that as developers we should be careful about? For example, if I start publishing or subscribing to information, I should be responsible in also making sure that I stop that, because clearly this is using different sensors, and I imagine there is a notion of power drain as you use this feature.
Yeah, Akshay and I are both looking at each other, nodding our heads. It's one very simple thing you can do. In your activities on stop method, call unpublish and unsubscribe. That's it.
Wow. Boom.
Okay. Done.
Yeah, because you're exactly right. Like, doing things with Bluetooth and doing this audio processing and like all these scan-ins, that does take some battery, and it's not the kind of thing that you want to have going on when you don't need it, basically.
Are there any other ways that a developer would possibly shoot his or her foot using these APIs? Like, is there something else that we should be careful about that isn't immediately visible from the outside?
Any leaks at all we should be aware of or anything? Like possible ways to leak?
I think we run Leak Canary, so I guess
nice. Okay.
it's a good tool, right?
Yeah, absolutely.
So I guess really unpublishing and unsubscribing, that's the first thing. Oh, I guess there is one sort of other gotcha. So one thing that developers sometimes don't expect is if you call publish for the first time in your app, like let's say the user hit the nearby button and they're like, all right, great, I want to do something with the people nearby. So you call publish, and then you get back in the result that, you need to ask for permission. And so then you ask for permission. And what happens there is then you get permission, but the publish didn't actually happen. You have to call publish again.
Oh, okay. Interesting.
And the same goes for subscribe. So that's kind of a gotcha where a couple people have been tripped up by it. And I can see why that's confusing, is you sort of expect I just granted the permission. Why didn't it finish? And the answer is you got to do it again.
Makes sense. I mean, it makes sense given how, once you understand how it works, it makes sense why you would have to do that. This
kind of makes it seem like it might fit into a reactive paradigm a little bit. Have you guys thought about that at all, or has anyone worked on anything in that regard?
Let's see. So, I guess the short answer is no. The way that we've sort of deal with it in our kind of internal test apps is we have a callback class that implements result callback, and in that callback class we sort of handle you need to ask for permission, and then basically doing that and then re-triggering the publish.
Gotcha. Okay. Now, we have discussed some of the general use cases of what you guys have seen typical developers using this for. But what are some of the craziest things you guys have seen this been used for so far?
I don't think anything like super crazy.
Triggering remote drones, getting self-driving cars as you walk by, nothing of that sort.
I don't know. Akshay and I are looking at each other like they all seem pretty reasonable.
I think at Google internally, people are always hacking around with proximity and trying to do interesting stuff. And there's some experiences we have that are just internal where you can walk into a conference room and we set up beacons in our conference room so that lets us interact and present from our phones when we're in the conference room just by using proximity with the beacon.
Oh, nice.
So there's cool use cases like that we've built.
Oh, there's the one where you can control the car with your phone.
Oh yeah.
Yeah. So you get close to the car and then you sort of like just, swipe left, swipe right, and just you can like drive around the car. So it's like completely driverless. That one's pretty cool.
Oh, wow. That's nice. Tell us more about that.
I made that up.
I was like, wow, sounds like a Wii remote for my car. Mario Kart real life.
That is not happening. That I know of, I guess I should say. Who knows?
That happened, but then Google realized they crashed too many cars and their employees, the insurance rates were going up. So they're like, nah.
Yeah, well, that's why we take the humans out of the equation.
There you go.
Yeah.
Now, do you guys have is there any security issues that I should be aware of when using Nearby at all? For example, if I wanted to use this for something payment related, would that be advised, not advised, or what's your thought process on that?
Well, because it's a broadcast, I don't know. I guess the way that I personally would think about it is I'd have the people who want to receive the payments like broadcast their identity and have the person who wants to send the payment, pick from those people.
Mm-hmm.
Okay. So it just depends on what you're passing.
Yeah, it depends on what you're passing.
Yeah.
Like if you were passing a token that would sort of allow people to take money from you and you made that available to anyone with the app within 100 feet, maybe you're okay with that, but might want to think twice.
From an analogy standpoint, you can kind of just think of it as your phone talking to the other devices that are around it. So it's kind of, if it's something you would say out loud in a room, like some kind of or some kind of identifier to something in your app that's already ACLed, or a list of people or devices that someone can pick from, then that's a lot more reasonable. But you definitely wouldn't want to send like your credit card number or payment information over Nearby messages. I think that would also probably violate some PCI thing as well.
Oh yeah, it does. Definitely does. Yep. Just wanted to make sure if there's any listeners wondering about security related stuff that we talked about that a little bit.
Early on, we mentioned that it would be very useful and convenient to quickly establish just the connection, as you mentioned with the multiplayer game. So even if it was like a payment service, right? If I wanted to quickly identify a person and just establish the connection, we could use Nearby, and then following that, you probably would use an internal service or a backend thing to sort of actually perform the transfer.
Yeah, I think that's right.
Okay. One last question I had from my side with respect to these use cases. So there was this device called the Locketron. That was a Kickstarter project. I'm not sure if you guys heard.
Yes, no, we're aware of it. Basically,
if I did want to send, it doesn't go through doors. So if I had a lock on my door and I wanted to use Nearby API, is that a possibility?
Well, the radio waves do go through walls and they do go through doors. So it's just the sound waves that don't. And you can sort of choose whether you want to use the technology or just the sound technology. So I think the ultrasound technology is maybe not the best application for doors because the phone's usually in your pocket and the ultrasound won't go through your pocket. But radio waves certainly will.
Okay, that makes sense. All right. So I think it was an excellent discussion, but we probably have to wind this show down at this point. But before we go, we will pick our awesome picks for the week. Let's start in alphabetical order.
Super. So I've been kind of these are sort of side project type things. I've been kind of playing around with some Android development just on the fun for giggles, I guess. And I really like vector graphics, these extremely high DPI screens. It feels like vector graphics should be kind of more popular than they actually are because they look so good on and so crisp on these high DPI screens. So I've been looking at a library called svg-android on GitHub, and it's kind of various forks. And it's pretty cool. It lets you like take an SVG file and like render it to a canvas. Like I think that's pretty neat. It's really easy to use. And kind of to go along with that, I've been learning Inkscape, which is this open source, drawing app. And I found these great tutorials on YouTube by this guy, Derek Banas. I might be pronouncing his name wrong, but we'll link it in the show notes. And it made it just like, this app is really complicated. It's got like a ton of power, so many different tools and options. And these tutorials make it really simple to kind of get started and like make things that look sort of credible, I think.
Very
cool. So those are my picks.
I did mention the GitHub project says that it's unmaintained or discontinued.
It is. So if you look at the forks of it, you'll find that like a lot of people think this thing is pretty useful because they've like a bunch of people have kind of like independently like, fixed this little reflection thing that didn't work on Android M. And they're like, okay, great. Now I made it work with Android M. Or they like, fix some other bug. So there's actually like a fair amount of demand for this. But yeah, I know.
I wonder if there was a company that built the operating system for my phone that could possibly do something like this.
Yeah,
I never know. I mean,
the truth is, I'm not an expert on Android UX at all, and I believe there actually is some native SVG support in Android. I just I'm such like a rank beginner when it comes to UI stuff that I don't feel qualified to talk about it.
No, but that's an excellent suggestion. I'm going to have a look at that as well. Akshay, what about you?
Cool. So I'm always a gadget freak, and I'm always playing around with new stuff that's on the market. So one thing I got recently was the Xiaomi Mi Band. So this is the fitness tracker. It's only $15 and most of them are still shipping from China, but they're super useful. It's basically a 3-axis XL on your wrist. And it's got a Bluetooth transponder to connect to your phone, and they have a really well-designed app that kind of syncs your data and lets you track steps. It does basic activity detection, sleep tracking, that kind of stuff.
Oh wow! Okay.
So yeah, I was really impressed just how much they packed in at a small price point. One interesting story though, and this is a caution to viewers out there who are going to order this, is be really, really careful if you're going to buy this on Amazon. Surprisingly, so the first time I ordered it, I actually, I got what was branded as like a Xiaomi original Mi Band, and it turned out to totally be a counterfeit device. It was another device.
Original was just the name of the company.
Yeah. The company's name was like Xiaomi Genuine. But, it actually ended up being something else called a Day Band. It had its own companion app on Android, which is just absolutely awful. It actually crashed the first time I launched it, and it just, I had to like complain about one thing I learned is on Amazon, when you're ordering things, look at the seller reviews, before you buy anything from someone who isn't like Amazon Prime or Amazon official. So I learned that lesson the hard way. But I finally got my Xiaomi Band the second time.
Yeah, it was a pretty nice looking device. Like the actual kind of like electronics part of it is so small. It's like almost a choking hazard. Cool.
All right, for me, just got two quick ones. One is actually, I may have brought this up before, but it's called Karma. It's basically a little Wi-Fi unit. And the only reason I'm bringing that up is because I've been without internet for 3 weeks now, and I've been living off this little Wi-Fi unit for the past week and a half. So it's been able to keep me connected somewhat to reply to emails and Instant Messenger. The one thing that's nice about it is it's kind of just pay as you go. So you don't have to pay $10 a month or anything like that. Like you just buy your data, and then if you don't use it all this month, that's fine. You can use it next month or in 3 months or whatever. So pretty useful. We'll add a link to the show notes for that. And then another one is a recent article that came out a couple of days ago about working remote. As most of the listeners probably know, I work remote 100% of the time. And there's a lot of things that come up when you start getting into working remote that you weren't aware of. And this article covers it very well. It's a very short read, maybe 2 or 3 minutes. But it's really great if you're interested in working remote or trying to figure out if it's for you or not. So I'll add a link to the show notes for that.
Perfect. And my pick for this week is a Chrome extension. It's called Google Tone. Initially, when I saw the video, I thought this was like one of Google's April Fool's project or the like. But it's a real thing, and it's amazing. And I think Andrew and Akshay mentioned it on the Material podcast as well. And this is pretty amazing. It's almost like a push bullet, but between two computers, and it emits this nice tone in between. So I'll add a link to the show notes, and the YouTube video that's attached probably does a better job in explaining what it is. But I thought it was pretty cool.
Yeah, a small story about that. The audio that's emitted by the tone extension is at least the audio that you hear is a DTMF tone, and so it sort of sounds like beeps and boops basically.
Yeah.
And
I was hoping you would actually you would sort of like make that sound, but I was like, come on, do it.
So I believe that the new Wi-Fi router that Google just released actually uses this same technology as part of the setup flow to sort of like verify that you've got ownership of the device you're setting up.
Oh wow, that's pretty cool.
Yeah, we think sounds like an interesting application for kind of like, making sure that you're in the same room with something.
Makes sense. All right, so if you want to get in touch with Donn, how do people do that?
You can reach out to me on Twitter at Donn Felker, that's DONNFELKER, or my website at donnfelker.com.
And you can reach me at my Twitter handle, Kaushik Gopal. How do people reach to you folks, Andrew and Akshay?
So on Twitter, I'm at Andrew Bunner.
Okay.
And actually, just by email, I'm akshayk@google.com.
Nice.
Awesome.
Thank you guys so much for coming on the show. It was a blast. I really enjoyed listening to this new way of doing things. And just a note, I think the Pocket Cast app is out today and they use the Nearby API. So if you folks are listening to this, you probably should start using this feature at this point.
Great. Thanks for having us, guys. It was a pleasure.
Thanks for coming on.
Thank you.